Hello guys, and welcome back to this channel. In today's video we are going to look at the topic binomial theorem. Now this happens to be the first series or the first video as far as this topic is concerned. In this video we are going to focus more on the Pascal's triangle. But before that, what is a binomial? Now a binomial is an expression which contains two terms connected by a plus or a minus sign. A binomial is an expression which contains two terms connected by either a plus or a minus sign. Now let's look at some examples of binomials. So examples of binomials, we have x minus y. This is a binomial because we have two terms and this is connected by a minus sign. Secondly, we can also talk about x plus y squared. This is also a binomial. And then lastly, we can talk of 2p plus q. So these are all binomials because they have two terms and they are either connected by a plus or a minus sign. Now you are familiar with this expansion, the expansion of a plus x to the power 2. Now this binomial is in the form a plus x raised to the power n. So comparing these two, you realize that the value of n is equal to 2. The exponent is 2. Now let's try and expand this binomial. A plus x raised to the power 2. Now in expanding this binomial, you realize that because it has the power of 2, you are going to multiply a plus x by itself. So you have a plus x times a plus x. Now let's expand. A times a is a squared. X times a is ax. X times a is ax. And then x times x is x squared. So when you simplify, you have a squared plus ax is 2ax plus x squared. So the expansion of a plus x raised to the power 2 is equal to a squared plus 2ax plus x squared. Now let's consider this scenario. So what happens if the value of n is increased to 3, to 4, to 5, and so on and so forth? Now you realize that as the value of n increases, the expansion by long multiplication becomes very tedious. Hence, you will need a quicker way of performing these expansions. So this leads us to the method of expansion by the Pascal's triangle, and the method of expansion by the binomial theorem. Now for the sake of this video, we are going to focus on the Pascal's triangle. Now let's focus on the Pascal's triangle. The coefficients in the binomial expansion of a plus x to the power n forms a pattern which is useful for small values of n. Now this pattern is what you call the Pascal's triangle. We are going to consider the following expansion for a plus x exponent n for integer values of n from 0 to 7. So these are the binomials. We have a plus x to the power 0, a plus x to the power 1, a plus x to the power 2, to the power 3, to the power 4, So how do we find the coefficient of these binomials? Now we know that any non-zero value raised to the power 0 is 1. So it means that for the binomial a plus x to the power 0, the coefficient is 1. Now to find the coefficient of binomials to form the Pascal's triangle, there are three most important things that you need to consider. Firstly, you should know that the coefficient of a binomial is 1 more than the power of the binomial. So you realize that the power of this binomial is 0 and the coefficient is 1. So always the coefficient of a binomial is 1 more than the power of the binomial. Now if that is true, then it means that if we have a plus x to the power 1, then the coefficients are going to be 2 values. Now this leads us to the second point. The extreme coefficients of any binomial is 1. So here, if the power of the binomial is 1, we are going to have 2 values, which means that we are going to have 1 and then 1, because the extreme coefficient values are supposed to be 1. Now let's move on to the third binomial, which is a plus x to the power 2. We are supposed to have 3 coefficients, and we know that the extreme coefficient values are supposed to be 1. So let's write 1 and then 1. Now how do we find the middle number? This leads us to our third point. In trying to find the middle coefficient, we are going to sum up the 2 adjacent coefficients immediately above the previous row. So we are going to add 1 and then 1 to give us 2. So it means that the middle coefficient is 2. Now let's move on to a plus x to the third power. So we have 1 and 1 at the extreme ends, and then we are going to add 1 and 2 to give us 3. We are going to add 2 and 1 to also give us 3. To the power 4, we have 1 and 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. At this point, I believe that you've been able to guess the trend. So we have 1, 1, 5, 10, 10, and then 5. We have 1, 1, 6, 15, 20, 15, and then 6. Lastly, we have 1, 1, 7, 21, 35, 35, 21, 7. Now this pattern formed by the coefficients is what we call the Pascal's triangle. Now in summary, we said that the coefficient of a binomial is 1 more than the degree of that particular binomial. So for this, we have a plus x to the 0 power, and then we have the coefficient to be 1. We have a plus x to the power 1, and then we have the coefficient to be 2 values. Okay, so we say that the coefficient of a binomial is 1 more than the degree or the power of that binomial. Secondly, the extreme coefficient values or the coefficient of the first and the last terms are always 1. So the coefficient of the first and the last terms or the extreme values are always 1. And then we also said that to find the middle numbers, you need to add up the 2 adjacent coefficients immediately above the previous row. So if you want to find this value, you are going to add 1 and 1 to get this value. And then one other important thing that you need to know is that the second and the second to the last terms are always equal to the power or the degree of the binomial. So the second term is 3, the second to the last term is 3, and then the power of this binomial is also 3. So always the second and the second to the last terms are equal to the degree or the power of the binomial. Now moving away from that, how do we find the expansion of a particular binomial? Assuming we are asked to find the expansion of a plus x to the power 3. Now in order to find the expansion of a plus x to the power 3, we are going to use the Pascal's triangle. From the Pascal's triangle, we know that these are the coefficients of a plus x to the third power. So we have 1, 3, 3, and 1. So basically the first thing is to write down the coefficient of the binomial. Now the sum of the powers of a and x should be equal to the power of the binomial in each term. So we are saying that the sum of the powers of a and then x should be equal to the power of the binomial in each term. Now we are going to include a and then x to form the expansion. So we write a and then x. Now the power on a is 3 and the power on x is 0. We are told that the sum of the powers of a and x should be equal to the power of the binomial in each term. So for this term, 3 plus 0 is 3, which is the power of the binomial, plus, now the power of a reduces from left to right and the power of x increases from left to right. So for the second term, you are going to have a to the power 2, x to the power 1. 2 plus 1 is still 3. Okay, now to the next term, we have a to the power 1, x to the power 2, and then for the last term, we have a to the power 0 and then x to the power 3. So you realize that the power of a reduces from left to right and the power of x increases from left to right. At the end, when you add the powers of a and then x for each term, it is supposed to be equal to the power of the binomial. So with the aid of the Pascal's triangle, let's move on to solve some examples. So in our first question, we are going to expand the binomial 2x minus 3y raised to the power 3. 2x minus 3y raised to the power 3. So first of all, let's rewrite the binomial. 2x minus 3y raised to the power 3. Now let's relate this binomial to a plus x raised to the power 3. So it means that by comparison, our a is 2x and then x is negative 3y. Okay, so we know that the coefficients of the binomial a plus x to the power 3 are 1, 3, 3, and then 1. So we can find the expansion of a plus x to the third power as 1a cubed plus 3a squared x plus 3a x squared plus 1x cubed. Now that we have the expansion of a plus x to the third power, let's substitute a and then x into this equation. So this becomes, we can leave out the 1. So a is 2x. So we have 2x to the third power plus 3 times 2x squared. And then we have x to be negative 3y plus 3 times a. We have a to be 2x times x squared. So times negative 3y squared plus negative 3y cubed. So let's simplify. 2x cubed becomes 8x cubed. 2 squared is 4. 4 times 3 is 12. So we have 12x squared times negative 3y plus 3 times 2 is 6. So we have 6x times negative 3y squared plus negative 3 cubed is negative 27. So we have negative 27y cubed. 8x cubed. Now 12 times negative 3 is negative 36. We have x squared and then y plus negative 3 squared is 9. 9 times 6 is 54. So we have 54 and then times x times y squared minus 27y cubed. So this is the expansion of 2x minus 3y raised to the power 3. Now let's move on to the next question. So for the second question, we are going to expand the binomial 2x minus 3 exponent 4. We are going to expand the binomial 2x minus 3 exponent 4. So first of all, let's relate 2x minus 3 exponent 4 to the binomial a plus x raised to the power 4. So by comparison, we have a to be 2x, and then we have x to be negative 3. Now the coefficients of the binomial a plus x to the fourth power are 1, 4, 6, 4, and then 1. So these are the coefficients. So we can say that a plus x to the power 4 is equal to a exponent 4 plus 4a cubed x plus 6a squared x squared plus 4a x cubed plus x exponent 4. So since we have the expansion of a plus x to the fourth power, let's substitute a and then x into this expansion. We have a to be 2x, so 2x to the fourth power plus 4 times 2x to the third power. We have x to be negative 3, so negative 3 plus we have 6 times 2x squared. We have x to be negative 3, so negative 3 squared plus 4 times 2x times negative 3 cubed plus negative 3 to the power 4. So now let's simplify. 2 to the fourth power is 16, so we have 16x exponent 4 plus 2 to the third power is 8. 8 times 4 is 32, so we have 32x exponent 3 times negative 3. 2 exponent 2 is 4, and then 4 times 6 is 24, so we have 24x squared times negative 3 squared is 9, okay, plus 4 times 2x is 8x, and then negative 3 cubed is negative 27. Negative 3 exponent 4 is 81. So this becomes 16x exponent 4. 32 times negative 3 is negative 96. 24 times 9 is 216. 8 times negative 27 is negative 216. And then we have plus 81. So the expansion of 2x minus 3 to the fourth power is equal to 16x exponent 4 minus 96x cubed plus 216x squared minus 216x plus 81. So for question number 3, we are to expand the binomial p minus q exponent 4. P minus q exponent 4. So let's relate p minus q exponent 4 to the binomial a plus x to the power 4. So we have a to be p, and then we have x to be negative q. Now the coefficients are 1, 4, 6, 4, and then 1. These are the coefficients. So the expansion of a plus x to the fourth power becomes a to the power 4 plus 4a to the power 3 x plus 6a to the power 2 x squared plus 4 times e x to the power 3 plus x to the power 4. Now let's substitute a and then x into this expansion. So we have p to the fourth power plus 4 times p cubed times negative q plus 6 times p squared times negative q squared plus 4 times p times negative q cubed plus negative q to the fourth power. Now let's simplify. We have p exponent 4 plus 4p cubed times negative q plus 6p squared times negative q squared plus 4p times negative q cubed plus negative q exponent 4. So this becomes p exponent 4 minus 4p cubed q plus 6p squared q squared minus 4p q cubed plus q to the power 4. So this is the expansion of p minus q to the fourth power. So for the last question, we are going to find the expansion of the binomial 3 plus 2x to the fifth power. 3 plus 2x to the fifth power. So we have 3 plus 2x to the power 5 equals a plus x to the power 5. So we have a to be 3, we have x to be 2x. Now we know that the coefficients of a binomial a plus x to the fifth power are 1, 5, 10, 10, 5, and then 1. So these are the coefficients. So the expansion of a plus x to the power 5 becomes a to the power 5 plus 5a to the power 4 x plus 10a cubed x to the power 2 plus 10a squared x to the power 3 plus 5a x to the power 4 plus x to the power 5. Now let's substitute a and then x into this expansion. So we have a to be 3. So 3 to the power 5 plus 5 times 3 to the power 4. We have x to be 2x plus 10 times 3 to the power 3 times 2x to the power 2 plus 10 times 3 to the power 2 2x to the power 3 plus 5 times 3 times 2x to the power 4 plus 2x to the power 5. So let's simplify this. So 3 to the power 5 becomes 243. So 243 plus 3 to the power 4 is 81. So we have 5 times 81 times 2x plus 3 to the power 3 is 27. So we have 10 times 27. And then this becomes 4x squared plus 10 times 3 squared is 9. and then 2 cubed is 8. So we have 8x cubed plus 5 times 3 is 15. 2 to the power 4 is 16. So 16x exponent 4 plus 2 to the 5th power is 32. So we have 32x to the power 5. We have 243 plus, now 5 times 81 times 2 is 810. So we have 810x plus 10 times 27 times 4 is 1080. So 1080 times x squared plus 10 times 9 times 8 is 720. 720x cubed plus 15 times 16 is 240. So 240 x power 4 plus 32x to the power 5. So this is the expansion of 3 plus 2x raised to the power 5. So that's it for today's video. I hope you enjoyed this section. Thanks for watching and see you in my next video. Bye bye.